Hello, students. Today we are going to discuss about flat slabs. So, typically, a flat slab is nothing but it's a slab where the slab is constructed monolically with a column, but without the provision of beams. So, the beams are not at all provided. Basically, if you have a cross section of the slab, this is how it looks. This is a column, and this is the slab. And between column and a slab, we provide a drop. So a drop is nothing but the reduced portion of a slab for rectangular. Normally, it is in shape of a rectangular or circular, and in between these two, this is called as a drop. This is called a slab. You can see, and this is column, and this is drop, and in between drop and column you can have a small portion which we call it as a column head. Normal this is provided to reduce the shear stresses. So the basically three parts are there: drop, column head, panel, or slab. So at some locations the drop is provided, some position drop is not based upon the step pan conditions and all those way to follow all those things. So IS 456 have defined few things. What is a panel? It was said. And what is a strip? Column strip. What is a middle strip? And what is drops? And how to calculate the bending moments? It was clearly mentioned in it. So we can directly go to design of a flat slab, and the flat slab normally where we use is in where you have huge spans. When you have a huge spans, normally what happens is the bending moments which are coming increases with the rate of the increase in the span. So so if the span is more, as because bending moments are more, you'll get the huge dimensions of the beam itself. So but now the beam becomes girder by itself. So girder, the main criteria is itself self weight. So if the self weight increases, the entire the structure the weight increases. So thereby you get the column sizes more, the foundations more, the deeper foundations, and all those sort of things. So where you have a huge spans, normally we can expect this in the commercial buildings, warehouses, and all that. So in commercial buildings where the beam aesthetically is not good in appearance, if you want to bring out that beam, there is a slab which you can do that, and that slab is nothing but a flat slab. So a flat slab is normally used in commercial and warehouses. So it's a design. It's different. So the entire the panel of the slab is divided into column strips and middle strips, and we calculate the column strip bending moments and middle strip bending moments in a shorter direction. In the same way, we calculate the middle strip bending moments and column strip bending moments in shorter spans, and based upon these values we calculate the stills and we distribute the stills and we detail the drawing. So we'll go ahead with the one example, then in the next video we'll go with another so with three conditions normally we have. So in the next problem we'll go with slabs without drop and column without head, and then we have slabs without drop and column with head, and a slab with drop and column head. So let's go to it. So the we are going to design an interior panel of a flat slab for a warehouse of 24 meters by 24 meters, which is divided into 6 by 6. So it in the question itself, it is given very clearly that 5 kilometer per square meter shall be taken into consideration, and you can have M20 grade concrete. And if this is only the data is given to you. So the size of the house is 25 by 24. You need to have 25 24 by big slab, where if the panel sizes is given as 6 by 4. So from clause 24 of IS 456, the thickness of slabs mechanism is spanned by 40, it comes to 150. Then thickness of drop you can assume as 1 by 4th of slab thickness, it comes around 50 extra thickness of slab where the column comes around. So the width of the drop you can take as half of the span length. So 600 say, so it comes at about 3000. Then we calculate column head diameter. Then we list out the mid strip properties, and we calculate the loading of slab, the live load on the slab, then the dead load on the slab is calculated. Then the ultimate bending moment can be calculated by this formula which was given in 31.4.2.2. And there were two conditions. So this is the formula. If you want to calculate the W, W is a total load which is coming for unit, and Ln is a clear span. So from this you can calculate directly the bending moment. So and this bending moment, whatever you get 280, is divided into column strip and middle strips in this ratios. And so this ratios is directly depend upon the alpha values which is given in the table of form. So by multiplying directly these values with the bending moments, you will get the bending moment positive and bending moment negative in the column strip, and in the similar way positive and negative moment in middle strip. So with these bending moments, we'll provide the steel, and we check our depth provided, and we calculate the steels, and we detail it. So this is it. It's very simple process, and I think we all can do this very simple, and this is the detail how it looks like. So normally negative still is provided at the upper portions of the column, and the positive bending moment still is provided at the center span which is extended to the columns also, and this process goes on. So and this is the two-way kind of slab that the steel is provided in this way also. So thank you for listening, and we'll in the next video, we'll have a discussion on flat slab without providing a drop and without a column head. So this is something, it looks like this, without drop and without column head. So how it is done, we'll see in the next class. Thank you.